Revolutionizing quantum computing, new 4D error correction codes achieve 1000x reduction in error rates. Introduction. On June 19, 2025, Microsoft CEO Satya Nadella announced a groundbreaking advancement in quantum computing, the development of new 4D error correction codes that achieve an extraordinary 1000-fold reduction in error rates. This technological innovation represents a critical step toward practical utility-scale quantum computing, promising significant implications for various sectors, particularly in cryptography and artificial intelligence (AI). The collaboration with Atom Computing to create a co-designed quantum system addresses both hardware and software challenges, paving the way for more reliable quantum platforms. Key highlights. 1. Impact on cryptography and AI. The significance of reducing error rates in quantum computing cannot be overstated, especially in light of the vulnerabilities faced by traditional cryptographic protocols. Cryptocurrencies, which rely heavily on cryptographic algorithms like SHA-256 and elliptic curve cryptography (ECC), may become susceptible to quantum attacks. This development has heightened concern among traders and investors, prompting them to closely monitor the cryptocurrency market for potential volatility linked to existing encryption standards. 2. Market response. Following the announcement, the cryptocurrency market experienced notable fluctuations. Bitcoin BTC initially dipped by 0.8%, trading at approximately $62,450 as market participants reacted to the news with caution. Conversely, AI-related tokens like Render Token, and Fetch.ai surged by approximately 4.7% and 3.9% respectively, reflecting the positive sentiment surrounding advancements in quantum technology. Quantum-resistant cryptocurrencies such as quantum-resistant ledger QRL also gained traction, reflecting investor interest in alternatives less vulnerable to quantum decryption threats. Additionally, Microsoft stock rose by 2.3% to $445.20, indicating a strong correlation between advancements in quantum technology and investor confidence in tech stocks. 3. Potential use cases. The advancements in quantum computing have far-reaching implications across various sectors. In AI, the enhanced reliability of quantum systems unlocks new possibilities for complex simulations, optimization tasks, and secure AI workloads. Industries such as finance, healthcare, and logistics can leverage these capabilities to improve operational efficiency and accelerate innovation, ultimately reducing time to market for new solutions. Timeline of events. June 19, 2025, Satya Nadella announces the breakthrough in quantum computing, emphasizing the significance of 4D error correction codes and the collaboration with Atom Computing. Market reactions. By the afternoon of June 19, Bitcoin's price was $62,450, reflecting early market jitters, while AI tokens began to gain traction. Stock performance. Microsoft shares rose to $445.20 by 2 p.m. Universal Time Coordinated, demonstrating investor optimism regarding the company's leadership in quantum technology. Analysis of market reactions. The announcement sparked significant activity in both the cryptocurrency and stock markets. Bitcoin's mild dip indicated initial market uncertainty, while the surge in AI tokens highlighted a growing enthusiasm for AI-driven innovations. Notably, RNDR climbed to $7.85, marking a 4.7% increase, while FET rose to $1.42, up by 3.9%. These movements underscore the interconnected nature of quantum computing advancements with market dynamics. Moreover, the correlation between Microsoft's stock performance and AI token rallies suggests that institutional interest in quantum technology is spilling over into the cryptocurrency market. This creates potential arbitrage opportunities for savvy traders, emphasizing the importance of monitoring cross-market sentiment and technical indicators. Differences between sources. While both sources underscore the significance of the 4D error correction codes and their implications for cryptographic security and AI, the first source provides detailed market reactions, including specific price changes for cryptocurrencies and stocks. In contrast,
the second source from Reddit focuses more on community discussions surrounding the implications of quantum advancements without offering specific market data.
Conclusion: the introduction of 4D error correction codes in quantum computing marks a substantial technical achievement with profound implications for both the cryptocurrency and AI sectors. As quantum systems become increasingly practical, stakeholders across various industries must adapt to the evolving landscape, particularly in terms of cryptography and AI applications. This technological shift highlights the intricate relationship between quantum advancements and financial markets, necessitating ongoing vigilance for both risks and opportunities. Future considerations: as quantum computing continues to evolve, further developments in quantum-resistant cryptography will be crucial for safeguarding digital assets against potential vulnerabilities posed by quantum decryption. Additionally, businesses must stay informed about advancements in quantum technology to leverage its potential for innovation and competitive advantage. The intersection of quantum computing and AI is poised to shape the future of technology with implications that extend far beyond the realm of computing. Investors, developers, and policymakers alike should remain engaged with this transformative technology, as the next wave of advancements could redefine the landscape of multiple industries, driving progress and opening new avenues for exploration and growth. In the context of the recent advancements in quantum computing, particularly the introduction of 4D error correction codes that significantly reduce error rates, several counterintuitive insights can be drawn from the content provided. 1. Market reactions to technological breakthroughs. Typically, one might expect that a significant technological advancement would lead to a surge in the prices of related assets, including cryptocurrencies and stocks. However, the initial reaction in the cryptocurrency market was a mild dip in Bitcoin's price, suggesting that market participants may have been more cautious than optimistic in the face of potential quantum threats to existing cryptographic standards. This highlights a counterintuitive caution among traders who are aware that advancements in quantum computing could potentially undermine the very security measures that underpin the value of cryptocurrencies. 2. Investment in quantum-resistant alternatives. While the announcement of improved quantum computing capabilities could lead to a rush towards traditional cryptocurrencies, the immediate market response included increased interest in quantum-resistant cryptocurrencies like the quantum-resistant ledger QRL. This suggests a counterintuitive shift in investor behavior, where rather than blindly investing in established cryptocurrencies, traders are actively seeking alternatives that are perceived as safer in a post-quantum world. The rise in prices of quantum-resistant tokens indicates a proactive rather than reactive market sentiment. 3. AI tokens surging amid quantum news. Another unexpected outcome is the rise in AI-related tokens like Render Token RNDR and Fetch.ai after the quantum computing announcement. One might presume that such a breakthrough in quantum computing would primarily benefit traditional tech companies or quantum-focused projects. However, the market reaction indicates that investors are linking the advancements in quantum computing with the potential for enhanced AI capabilities, suggesting a broader interpretation of value creation that extends beyond direct applications of quantum technology. 4. Investor confidence in tech stocks. The increase in Microsoft's stock price following the announcement of the quantum computing breakthrough contrasts with the decline in Bitcoin, indicating a divergence in market sentiment. While one might expect a uniform reaction across tech and crypto markets, the data shows that institutional investors are more confident in established tech companies' ability to leverage quantum advancements for growth. This suggests a nuanced understanding of risk and opportunity, where traditional tech stocks are perceived as more stable investments compared to the volatility of cryptocurrencies. 5. Caution versus optimism in quantum advancements. The narrative surrounding quantum computing advancements often emphasizes its transformative potential across industries. However, the initial market responses indicate a cautious optimism rather than outright exuberance. Investors are weighing the potential benefits of quantum advancements against the risks they pose to existing systems, leading to a complex interplay of caution and opportunity that might not align with the typical hype associated with breakthrough technologies.
6. Interconnectedness of markets. The correlation observed between Microsoft's stock performance and the cryptocurrency market. Particularly AI tokens suggests a counterintuitive dynamic where advancements in one sector, quantum computing, can have significant ripple effects across unrelated sectors, AI and crypto. This interconnectedness challenges the notion of isolated market reactions, indicating that advancements in technology can alter investment landscapes in unexpected ways. 7. Focus on future-proofing investments. The rise of quantum-resistant cryptocurrencies highlights a trend where investors are not merely reacting to current technologies but are actively seeking to future-proof their investments against the inevitable rise of quantum computing. This proactive stance is counterintuitive in that it shifts from a focus on immediate gains to a long-term view of asset security and viability in a rapidly evolving technological landscape. These counterintuitive insights reflect a complex and evolving relationship between technological advancements in quantum computing, market reactions, and the broader implications for various industries, particularly in the realms of cryptocurrency and artificial intelligence. Key overlooked aspects of the 4D error correction codes breakthrough. While the announcement of 4D error correction codes achieving a 1000x reduction in error rates in quantum computing is groundbreaking, several nuanced implications and lesser discussed aspects merit attention. These points are significant not only for their technical relevance but also for their broader impact on industry's markets and future technological developments. 1. The technical foundation of 4D error correction codes. Many discussions surrounding the announcement focus on the implications rather than the underlying technical advancements. The significance of 4D error correction codes lies in their ability to manage both spatial and temporal errors in quantum systems. The codes allow for more efficient qubit usage and provide a framework that could be scaled for practical applications. Understanding this technical foundation is paramount because scalability. The design principles behind 4D codes may inspire future innovations in error correction across various quantum architectures, enabling more scalable quantum systems. Trapdoor functions. These codes may also improve the robustness of quantum algorithms used in cryptography, making them more resistant to attacks. As cryptography evolves, the interplay between quantum error correction and secure communication will be vital. 2. Implications for quantum-resistant cryptography. While there is mention of the vulnerability of current cryptographic standards like SHA-256 and ECC to quantum attacks, the discussion often overlooks the urgent need for transitioning to quantum-resistant cryptography. The significance here is twofold. Risk of obsolescence. As quantum computers become more practical, existing encryption methods could become outdated. Businesses and governments must invest in developing and adopting quantum-resistant algorithms now to safeguard sensitive data. Market demand. The shift toward quantum resistance will create a burgeoning market for new cryptographic solutions, driving innovation and investment in cybersecurity technologies. 3. Market dynamics and behavioral economics. The market reactions following the announcement provide a textbook case of behavioral economics in action. The fluctuations in cryptocurrency values, particularly the drop in Bitcoin prices alongside the rise of AI-related tokens, reveal deeper patterns in investor psychology. Fear and uncertainty. The immediate response to news about quantum vulnerabilities indicates a fear-driven market. Investors may be driven to seek safer assets, affecting market stability. Opportunistic investments. Conversely, the rise in AI-related tokens reflects a trend where investors pivot towards sectors seen as future-proof. This behavior underscores the interconnectedness of different technological advancements and market sentiments, which could lead to further volatility. 4. Broader industry implications beyond quantum computing. The advancements in quantum computing and their intersection with AI highlight a transformative shift that goes beyond immediate applications. Cross-industry innovation. Companies in sectors like healthcare, finance, and logistics will increasingly leverage quantum computing capabilities to solve complex problems. This transformative potential for AI applications is significant for industries lacking computational power to handle large datasets effectively. Ecosystem development. The collaboration between tech giants like Microsoft and startups like Atom Computing exemplifies how partnerships are crucial for fostering innovation. This ecosystem approach can accelerate the development of quantum technologies and AI, leading to rapid advancements across multiple sectors.
5. Regulatory and ethical considerations.
The rise of quantum computing brings forth ethical and regulatory questions that are often sidelined.
Data privacy and security, as quantum computing could potentially break existing encryption.
Regulatory bodies will need to create frameworks that ensure data protection in the face of evolving technologies. The urgency for updated regulations is paramount to ensure consumer trust. Equity in technology access. The risk of a technological divide could widen as only certain companies or nations might effectively harness quantum advancements. There is a pressing need for inclusive policies to ensure equitable access to these technologies across different socioeconomic groups.
6. Long-term investment in quantum research.
While immediate market reactions are significant, the long-term implications of this breakthrough also warrant attention.
Many investors may overlook the importance of sustained investment in quantum research.
Funding and resources. Continuous funding for quantum research is essential for overcoming existing challenges. A failure to invest could lead to stagnation, slowing the pace of innovation.
Talent development. As quantum technologies evolve,
there is a growing need for talent skilled in quantum computing.
Educational institutions must adapt curricula to prepare the next generation of scientists and engineers. 7. Potential for unforeseen applications. Finally, the announcement opens the door for innovative applications that may not be immediately apparent.
New business models. Quantum advancements could lead to entirely new business models and services, particularly in AI-enhanced decision-making and predictive analytics. Environmental applications. With improved computational capabilities, quantum systems could play a significant role in environmental modeling and addressing climate change challenges, a factor that extends beyond traditional business metrics.
Conclusion.
In summary, while the announcement of the 4D error correction codes represents a significant leap forward in quantum computing, the broader implications of these advancements are complex and multifaceted. From technical foundations and market dynamics to ethical considerations and potential applications, the landscape shaped by this breakthrough will require careful navigation by businesses, investors,
and policymakers alike. Recognizing and addressing these overlooked aspects will be crucial for maximizing the benefits of quantum advancements in the coming years. 1. Significance of 4D error correction codes. The introduction of 4D error correction codes that reduce error rates by 1,000 times represents a monumental step towards practical quantum computing.
This advancement addresses long-standing challenges in hardware reliability and computational accuracy, making utility-scale quantum systems feasible. Such breakthroughs are vital for harnessing the full potential of quantum technologies across various sectors, particularly in cryptography and AI. 2. Implications for cryptography. The development of quantum computing capabilities poses a significant threat to traditional cryptographic protocols such as SHA-256 and ECC, which underpin the security of cryptocurrencies. As quantum systems become more powerful, these encryption methods risk becoming obsolete, leading to potential vulnerabilities in the cryptocurrency market. This has created a sense of urgency among investors and traders to seek quantum-resistant alternatives, highlighting the need for innovative cryptographic solutions that can withstand quantum attacks. 3. Market dynamics and reactions. The announcement of this quantum breakthrough has triggered notable fluctuations in the cryptocurrency market and tech stocks. For instance, Bitcoin experienced a slight dip while AI-related tokens surged, reflecting a shift in investor sentiment and market dynamics. The correlation between advancements in quantum computing and stock performance, particularly for companies like Microsoft, underscores the growing intersection between tech equities and digital assets, creating new trading opportunities and risks for investors. For potential use cases in industry applications, the enhanced reliability and performance of quantum systems unlock new possibilities for AI and other industries. Businesses can leverage quantum computing for complex simulations, advanced optimization tasks, and secure AI workloads, which can lead to faster innovation and reduce time to market for new solutions in sectors like finance, healthcare, and logistics. The convergence of quantum computing and AI technology not only enhances operational efficiencies but also drives competitive advantages in an increasingly data-driven landscape. Here are 3 famous historical cases that align with the theme of revolutionary advancements in technology and their impacts on society. 1. The invention of the printing press, 1440. Johannes Gutenberg's invention of the movable type printing press marked a monumental shift in the dissemination of information. Prior to this innovation, books were laboriously copied by hand, making them scarce and expensive. The printing press enabled the mass production of books, leading to an unprecedented spread of knowledge, literacy, and education across Europe. This revolutionized not only the publishing industry but also contributed to the Renaissance, the Reformation, and the scientific revolution, fundamentally changing the fabric of society in the process. 2. The Industrial Revolution, 18th to 19th century. The Industrial Revolution was a period of profound technological transformation that began in Britain and spread across the globe. Innovations such as the steam engine, spinning jenny, and power loom drastically altered manufacturing processes, leading to the rise of factories and mass production. This shift not only increased productivity but also transformed labor markets, urbanization, and social structures. The Industrial Revolution laid the groundwork for modern economies and altered daily life, creating a new era of economic and social dynamics. 3. The rise of the Internet, late 20th century. The creation and expansion of the Internet have arguably been one of the most transformative technological advancements in human history. Initially developed for military and academic purposes, the Internet has become a global communication platform that connects billions of people. It revolutionized industries including media, commerce, and entertainment, and has profoundly affected how individuals interact with information and each other. The rise of social media, e-commerce, and online education are just a few examples of how the Internet has reshaped society, economies, and cultures worldwide. These cases exemplify how technological advancements can lead to profound societal changes, much like the recent breakthroughs in quantum computing that promise to impact fields such as cryptography and artificial intelligence. Future outlook: the impact of 4D error correction codes in quantum computing. The recent announcement regarding the development of new 4D error correction codes by Microsoft, which achieve a staggering 1000x reduction in error rates, heralds a transformative era for quantum computing. This advancement is poised to revolutionize various industries, particularly cryptography and artificial intelligence (AI), and offers a glimpse into the future implications of quantum technologies. 1. Quantum computing and cryptography. With the advent of quantum computing, traditional cryptographic systems are at risk of becoming obsolete. The introduction of 4D error correction codes not only enhances the reliability of quantum systems but also raises concerns over the security of existing encryption methods such as SHA-256 and ECC. As quantum computers become capable of breaking these algorithms, industries relying on these cryptographic standards, particularly the financial sector and cryptocurrencies, will need to pivot towards quantum-resistant algorithms. Predictions: by 2030, we may witness a widespread transition to quantum-resistant cryptography across major financial institutions, driven by emerging quantum threats. Regulatory bodies will likely mandate the adoption of post-quantum cryptographic standards, leading to a surge in demand for secure solutions. 2. AI and quantum computing integration. The enhanced capabilities of quantum computing will significantly boost AI applications.
Industries such as healthcare, logistics, and finance can leverage quantum systems for complex simulations and optimization tasks,
leading to faster innovation cycles and improved decision-making processes.
Predictions.
By 2028, AI models utilizing quantum computing could achieve breakthroughs in drug discovery and personalized medicine, drastically reducing the time required for research and development.
We will likely see the emergence of hybrid quantum classical algorithms that optimize AI workflows, enhancing the efficiency of various applications. 3. Market dynamics and investment trends. Following the announcement of 4D error correction codes, the financial markets responded with notable fluctuations.
Companies engaged in AI and quantum technologies saw a surge in stock prices, while cryptocurrencies faced volatility as investors reassessed the implications of quantum advancements.
Predictions.
By 2027, AI-related stocks may consistently outperform traditional tech stocks as institutional investors increasingly recognize the potential of quantum-enhanced AI solutions. The cryptocurrency market will likely fragment, with a growing number of quantum-resistant tokens emerging as alternatives to existing cryptocurrencies,
gaining prominence among risk-averse investors. 4. Quantum computing accessibility.
As quantum technologies mature, the barrier to entry for utilizing quantum computing will decrease, leading to broader adoption across various sectors. Companies will begin to integrate quantum solutions into their existing infrastructure, facilitated by cloud-based quantum computing services.
Predictions.
By 2029, small to medium enterprises (SMEs) will increasingly adopt quantum computing solutions, harnessing them for competitive advantage in areas such as logistics optimization, predictive analytics, and supply chain management. Educational institutions will likely expand quantum computing curricula, leading to a skilled workforce ready to innovate with quantum technologies by the end of the decade.
5. Ethical considerations and governance. As quantum computing capabilities expand, ethical concerns surrounding its applications will intensify. The ability to break encryption and access sensitive data poses significant risks, necessitating robust governance frameworks to guide the responsible development and deployment of quantum technologies. Predictions. By 2030,
international coalitions may form to establish ethical guidelines and regulatory standards for quantum computing, focusing on data privacy and security. Public awareness campaigns will likely emerge to educate society on the implications of quantum advancements, fostering a more informed discourse on its societal impacts.
Conclusion.
The development of 4D error correction codes represents a pivotal moment in the evolution of quantum computing, with far-reaching implications for cryptography, AI, and market dynamics. As we move toward a future where quantum technologies become mainstream, industries must adapt to the new landscape, preparing for both the opportunities and challenges that lie ahead. Continuous innovation, ethical considerations, and proactive governance will be crucial in shaping a future where quantum computing serves as a force for good, driving progress across various sectors and enhancing the security and efficiency of our digital world.